When you think about the internet, what comes to mind? Probably websites, right? Or sending an email, maybe streaming your favorite show. Well, all that magic, everything we actually do online happens on one specific level, the application layer. You can think of it as the internet's top floor, the one we all hang out on every single day. So let's take a look at how it was built.
To get our heads around this, let's start with a simple question. Where does the internet actually begin for you? Is it when you open your browser and type in a web address? Or maybe when you tap on an app on your phone? That exact moment, that first point of contact, that's the application layer.
Now, the technical answer to that question is the application layer. The official definition calls it an abstraction layer, which, sounds complicated, but it's really just a way of saying it's a user-friendly interface that hides all the super complex stuff happening underneath. It's the bridge between the software you see on your screen and the giant messy network that makes it all work.
But of course, this top floor wasn't just built by accident. Way back in the early days of networking, engineers needed some kind of plan, a blueprint to organize all the chaos. And this led to two major competing philosophies for how to structure a network, especially when it came to that all-important layer that we, the users, interact with. So these two blueprints, they actually popped up at roughly the same time, but they had very different goals. Back in the 70s, you had TCP/IP, which started as a practical get-it-done project for what would eventually become the internet. Then, a little later, the OSI model came along with a much grander vision to become the one universal standard for all computer networks everywhere. And this chart, well, it shows the difference perfectly. On the left, you've got the superstructured 7-layer OSI model, and on the right, the much leaner TCP/IP suite. Now look at the top. See how the OSI model splits everything out into 3 separate layers? Application, presentation, and session. But TCP/IP, it takes a totally different approach. It just bundles all of that into one single powerful application layer.
Now, this difference, it's not just some nerdy academic detail. It really represents a fundamental clash in design philosophy. It's a tale of two very different ways to build that top floor of the internet. And believe me, the outcome of this debate is the reason the web works the way it does today.
So the OSI approach was all about being precise and orderly. It was very academic. The idea was that every layer should have one very specific job. The session layer would manage the conversation, the presentation layer would handle formatting the data, like making sure computers agree on how to represent text, and the application layer was just the final doorway to the program. Super clean, very logical, at least in theory. TCP/IP, on the other hand, was way more pragmatic. Its designers basically said, you know what? Separating session management, data presentation, and the application, that's just not necessary. So they bundled it all together. This created a simpler, more flexible, and, as it turned out, a much more robust layer, where the applications themselves could handle all those different tasks, if and when they needed to.
So here's the bottom line. OSI was aiming for theoretical perfection with its narrow scope and strict rules. It was a beautiful model on paper, a true academic standard. But TCP/IP, with its much broader scope and focus on just being simple and flexible, became the practical foundation of the actual working internet. It was theory versus practice, and this time, practice definitely won.
Okay, so what did this practical approach actually lead to? Well, this super flexible application layer became the home for all the specialized languages or protocols that we now use every single day to get around in the digital world. You should think of these protocols as specific rule books for different jobs, right? You need one set of rules for sending an email, a completely different set for loading a web page, and yet another for downloading a file. The application layer is basically the library where all these different rule books are stored and ready to be used. For example, when you're browsing the web, your computer is speaking a language called HTTP to ask servers for web pages. When you send an email, that's your mail app using SMTP to push it out into the world. And when you check your inbox, that's POP, pulling the mail down from the server. These are the invisible workhorses of our daily online lives.
And then there are other protocols working behind the scenes. Ever wonder how your browser actually finds a website when you type in the name? That's DNS, the Internet's phone book, translating those human-friendly names into the numbers computers understand. Need to move big files around? The classic is FTP. And then BitTorrent came along and completely changed the game, letting users share files directly with each other, peer-to-peer. All these totally different languages live together, side by side, in the application layer.
So why does any of this matter so much?
Because the decision to go with TCP/IP's simpler, more flexible model didn't just set a technical standard, it literally unlocked the explosive innovation that created the web as we know it.
This quote right here, it gets to the absolute heart of it. By keeping the core of the network simple and pushing all the smarts and complexity out to the edges, out to the applications themselves, the designers of TCP/IP created a system that was unbelievably adaptable.
And this right here is the key takeaway. Because the application layer is so open, anyone can invent a brand new protocol for a new idea. It doesn't matter if it's for streaming video or instant messaging or some new kind of social media. You don't need to ask for permission, and you don't have to rebuild the internet's foundations to do it. This idea is called permissionless innovation, and it's the reason the internet has evolved so incredibly fast.
So all of this leaves us with a really fascinating question. From the web itself to file sharing, the application layer has been the birthplace of world-changing ideas. As we head into a future of AI, the metaverse, and the Internet of Things, what new protocols, what new languages are going to be invented on the Internet's top floor? And what will they let us do next? Thanks for tuning in.